covariance and correlation. Before we get to covariance and correlation, let's remind ourselves about a variance in a variable. Let's say we have a variable that varies and the mean of that variable is shown here as x bar. If we want to compute the variance, then what we mean by the variance of this variable is the distance of each data point from the mean or the average point. So for each data point, we measure the distance and we add them up, and all those distances are squared so that we get rid of the sign value and we can add them up where the minus will not affect the pluses to cancel off because we are squaring it. Once we have done it, we divide that by the sample size minus 1 or the degree of freedom, and that's called the variance in a given variable. When we have two variables, each variable will have its mean and variance. Variable x will have its mean x bar and its variance, and variable y will have its mean y bar and its variance. If you want to look at the relationship between these two variables, we can look at this relationship by looking at the variation of the two variables. Let's say we have on the y variable person who is doing the rock climbing, and on the x variable person who is running, and we want to look at when the person climbs to the top, how long has the person has run on the x-axis. We can look at the distance, the variation in the distance of each variable, and then look at an association or a relationship. But the distance can be measured in different ways, for example, kilometers and miles. And in a model, statistical model, we can look at the outcome using these variables, and the steepness of the relationship is being expressed using the b or the parameter of the x in the model, along with a component of the error. When we want to establish relationships, associations between two variables, we can look at the unstandardized values. For example, on the x-axis, the distance was measured in kilometers, and on the y-axis, the distance was measured in meters. Unstandardized values, but still we can establish an association based on those values, and that's called the covariance. On the other hand, we can say the measured values are different because they use different yardsticks, and we can standardize those values using standard deviation. If we standardize those distances, we can come up with an association, and that's called the correlation. Let's look at how we compute covariance and correlation. There are two variables, x and y. So the variance is the deviation from the mean. So first we look at the variation of each variable. So we look at the variance of each variable. For the x, for each observation, we compare with the x bar and we take the distance difference, and for the y, we look at the y bar and then look at each data point and take the distance. So when we add all the distances for the x variable, gives us the variance for the x variable, and when we add all the distance for the y variable, we get the total distances for the y variable, total variance for the y variable. And we multiply that. We multiply the two products and we divide by n minus 1, or the degree of freedom, and that's called the covariance between x and y. To standardize it, to come up with correlation coefficient, what we need to do is we took the variance, total variance for x variable, but we standardized by dividing by the standard deviation of the x variable. And we took the total distance or the deviation of the y variable, we standardized by dividing by the standard deviation of the y variable. Once we have standardized the two variances, we divide the product of the two by the degree of freedom, or n minus 1, and that gives us the correlation coefficient denoted by a little r.